Let's take a look at a normal distribution and talk about how to find probabilities. So I encourage you to pull out your Z table and your TI graphing calculator because I'm going to show you how to solve these types of problems using both methods. All right, we're told that the heights of adult women are normally distributed with a mean of 64 inches and a standard deviation of 3 inches. So my recommendation is anytime you read a problem where you know or you're being told that your data is normally distributed, immediately make a sketch of a bell-shaped curve like what I have down below. So even if the problem doesn't tell you to make a sketch of the normal distribution, you should go ahead and do that. And then off to the side, write down your population mean. So here that mean is 64 inches, and your population standard deviation, which in this problem that's 3 inches. Okay, once you have that bell-shaped curve, go ahead and make a sketch of the normal distribution for women's heights, where the mean is going to be at the center of your distribution, and then show the z-scores. So write down the z-scores that are 1, 2, and 3 standard deviations above the mean, and 1, 2, and 3 standard deviations below the mean. So in blue here, these are the z-scores that correspond with the heights that's measured in inches. Okay, so the mean height is 64 inches, and if the standard deviation is 3, then that means a height that is 1 standard deviation above the mean is going to be a height of 67 inches. A height that is 1 standard deviation below the mean is going to be 61 inches. And then a height that is 2 standard deviations above the mean, that's going to be 70 inches. And then a height that is 2 standard deviations below the mean, that's going to be 58 inches. And then let's take it out 3 standard deviations. So a height that's 3 standard deviations above the mean is 73 inches, and a height that is 3 standard deviations below the mean is going to be 55 inches. Okay, so now we can actually take a look at this first question that's asking us, what is the probability that a randomly selected female in the United States is going to be taller than 62 inches? So I'm going to rewrite this question using the probability notation. So I want to know, what is the probability that a randomly selected female, so let X be the height of a female in the United States, okay, and that the height is going to be taller, so greater than 62 inches. And so to answer this, remember, probabilities correspond to an area under the curve. So let's go ahead and shade the area under the curve that represents all the heights that are greater than 62 inches. So here I'm going to mark 62, which is about right there. And again, your drawing doesn't have to be perfectly drawn to scale. It's just you want to draw enough to give yourself an idea. So if I'm looking at heights above 62 inches, I'm looking at the area under the curve. That is to the right of 62 inches. So let me shade that in red. So I'm trying to figure out what is the area under the curve that is this red shaded region here, okay? So hopefully you can see that we know for sure that that probability is going to be more than 50%, because if I divide my data exactly in half here, you can see that the left half is 50% of the female heights, and then to the right, we'll find the other 50% of female heights. Okay, so how are we going to calculate that probability? So what is P of X greater than 62? I'm going to show you first how to use the Z table, and then I'll show you how to use your calculator. So here, if you're using the Z table, then the first thing we need to do is we need to take 62 inches. So when X is 62 inches, I need to figure out what is the Z score for a height that is 62 inches. So according to my drawing here, I hope that you will agree with me that the z-score for a height of 62 inches is going to be somewhere between -1 and 0. So to figure out what that is exactly, we're going to use the formula for calculating a z-score, and that formula is take x, see how far away it is from the population mean, and divide by the population standard deviation. So that's 62 minus 64 divided by 3. And we typically round our z-scores to 2 decimal places. So that gives me a z-score of 0.67. So this tells me that the z-score for a height of 62 inches is -0.67, which is between -1 and 0, just like we expected. Okay, now how do I figure out the area that corresponds to a z-score of -0.67. And so to find that area, we're going to first go to our z-table. Your z-table, there are two sides to the table. On one side, you've got all the negative z-scores, and then on the other side, you have all the positive z-scores. Okay, so just recall that we just converted 62 inches to a z-score, which was -0.67. So I'm going to go to the negative side of my z-table, and you're going to scroll down in the first column, and you're going to look for -0.6. So -0.6 is here, and then go to the column that corresponds with 0.07. So that's this column here. And when you take a look at the z-table, you'll see I'll circle it in red here. All right, that gives us an area of 0.2514. So let me explain real quickly how you use the z-table. So here on this first column and this first row, that's how you find your z-score. And then the body of the table here, these numbers represent probabilities that correspond to an area that is to the left of that z-score. So let me draw that bell-shaped curve up here again real quickly. So we've got 0, -1, and then we've got -0.67, okay? So a height of 62 inches corresponds with a z-score of -0.67. And so when I go to the table and I take a look at that area, which is 0.0254, that 0.0254 represents the area that is to the left of that z-score. So anytime you're looking at the numbers in the body of the z-table, it always represents the area that's to the left of the z-score. Okay, so the area to the left of a z-score of -0.67 is an area of where's my pen? 0.2514. Okay, now remember the question that we were trying to answer was we wanted to know what is the probability that the height of a randomly selected female is going to be greater than 62 inches. So greater than 62 inches means the area to the right of that z-score of -0.67. All right, so the table gives me the area to the left, but I know that the total area under the curve equals 1. So to find the area to the right of that z-score, you simply take 1 and you subtract the area to the left. So that's 1 minus 0.2514, which gives me an area of 0.749. And areas under the curve correspond with probabilities. So to answer that question, what is the probability that a randomly selected female is greater than is going to be taller than 62 inches? That probability is 0.749, or you can think of that as 74.9%. So there's a 74.99% chance that a randomly selected female is going to be taller than 62 inches. Okay, now let's take a look at how we can use our calculator to calculate the probability that a randomly selected female is going to be taller than 62 inches. So again, go back to your bell-shaped curve and mark where 62 inches is on the curve. And we are interested in finding the probability that a randomly selected female has a height that's taller than 62 inches. So I'm interested in the area that is under the curve shaded in red. So that's going to give us the probability that X is greater than 62 inches. Okay, so on your calculator, what you're going to do is you're going to press the second button and the VARS button. And you'll see right above VARS in blue is DISTR, which stands for distributions. When you click on second VARS, you get to the distributions, you're going to choose option 2, which is called Normalcdf. So I'll write up here. You're going to use Normalcdf. Guess what CDF stands for? Continuous density function. So this is a probability function, and we said earlier that probability distributions are just a continuous density function. So that gives us that curve, okay? All right, your calculator is then going to ask you to put in some information. So here it's going to ask you to put in a lower bound. So this is why the drawing is going to be really helpful, and why this is also why I encourage you to make a sketch of that bell-shaped curve. So here, because I'm interested in the area of that red shaded region, you can see from the picture that 62 is going to be my lower limit. Okay, and this is a continuous density function. So even though we only identify the heights out to 3 standard deviations from the center, okay, this function actually continues on and on both sides. And so for an upper bound, okay, again, this function is continuous. So for the upper bound, you want to put in a value that is very, very large. So your textbook says that you can use a number that is very large, like 999,999. So that would be, in this particular example, a height that is 999,999 inches tall. Now, I know that doesn't make any sense in the real world, but basically what you want to do is you want to just put in a very, very large number. So on your calculator, you can type in a very large number by typing in 1E99. So let me show you how you can type that into your calculator. So you're going to press 1, and then to get that E button, you're going to press second and then the comma sign. And right above the comma sign, you'll see EE, double E. It's going to show up as just E, and then you're going to type in 99. Okay, so that tells me that my upper limit, so that's 1E99. Okay, that's going to be your upper limit. And then the calculator is going to ask you to type in mu and sigma. So you're going to type in your population mean and your population standard deviation. Then go ahead and press enter, and you'll see that when you press enter, it gives you the probability. So the graphing calculator is a very nice tool to use. On your exams, I'm going to ask you to show your work. So if you're using your calculator to show your work, you're going to simply write down that you use Normalcdf and then indicate what your lower limit and your upper limit are, and then also indicate your mean and your standard deviation. So this is what you would do. I'll box it up at the top here. This is what you would do to show your work, okay? And then you can also then say, and that is equal to 0.748. Which hopefully you will see that that's the same answer we got when we used the z table.